right. Thank you so much. Just a few quick reminders for you before we begin today. You do have a quiz that has posted this morning. It will cover chapter 3. Now, a couple of things that I will mention. Once again, what I have done is I have done a question pool. So I've pulled questions from all over chapter 3, and it will randomly pick about 10 of them for you to basically take the test with. So you might get new questions every time. Now, I mentioned on Wednesday that I will not be testing you on prenatal development, and I did actually record audio that I basically included everything from genetic development, and then I skipped prenatal development and I just jumped into infancy. There might be some questions on prenatal development on your quiz, but the quiz is pretty short and the section on prenatal development is pretty short. So if you need to read that really quickly and answer the question, I'm fine with that. But most of the questions will cover a lot of other stuff in the chapter besides that. Okay, let's go ahead and share screen. I promised lots of videos of cute children today, and I was not kidding. Also, if you would, keep a couple of my nieces in your thoughts. I found out on Wednesday afternoon or Wednesday evening that my 11-year-old niece, who is the she's the second from the youngest, she has COVID. She'll probably be okay, but I did send her a care package. And then the youngest, who is 8, has to be quarantined as well until October. So I bought them Squishmallows. Hopefully they think I'm a good aunt. I just hope that the teenagers aren't like, we want something too. Like, here you go, gift cards to Sephora. They love makeup. All right, well, one of them does. Okay, so the last time that we were here, we were talking about Piaget's stages of cognitive development. And just to kind of give you a reminder of what we were talking about last time, Piaget very, very strongly believed that children are active thinkers. They don't think like adults. They have unformed ideas of the world that they learn about through experience. And they are constantly testing their ideas about the world. And the feedback that we give them helps them learn from experience. And it's incredibly useful for them in building what we call a schema. A schema is a concept that helps us organize information. And even as adults, you all have schemas. So for example, next week, Freddy's Steak Burgers opens up on the other side of town. How many of you are probably going to go at some point? I've never been there, but I've heard it's pretty good. But we've never had a Freddy's Steak Burger here. And some of you may have never actually gone to one. I never have. Am I going to walk inside of this fast food restaurant and go, oh my gosh, I have no idea how any of this works. This is so new to me. We don't do that. We have an idea of what a restaurant and a fast food restaurant looks like, when you're supposed to pay for your food, where you're supposed to wait for your food, and what kind of food will be served. That's a schema, and we all have one. And it helps you adapt very quickly to new experiences. So schemas just aren't for children. We have them too. So I mentioned this last time with our example of Gabriella. Gabriella had an idea that all cows were hairy, four-legged animals. It turns out that moose are not cows. And so so in this case, Gabriella had to engage in a process called accommodation. You modify and adjust your schema based on feedback. So for example, Dr. Roy was telling me about this, and I hope it's okay to share. I'm sure it is. It's not too embarrassing. But when she was a kid, she thought that goats were basically baby cows. They look similar. They're pretty furry. They have never mind that goats have rectangular pupils, which I think is so cool. I love goats. I would have one but I'm worried I would try to feed cans to it because I'm from suburbia. Like, I'm from suburbia. We didn't have like wild animals or go to farms or things like that. So I'm like, a goat, they eat everything. I could feed cans to it. That's probably not a good idea to do with a goat. So it's better for everybody that I don't have one. So if you believe that a cow is a goat or a goat is a cow, and you get feedback from your parents or from other people that cows and goats are separate things, you can then narrow your understanding of what a cow is and then modify and create a new schema that tells you what a goat is. Now, I mentioned last class that we all have experience with different types of dogs. When I was growing up, so many of you have seen Smedley at this point. And if you haven't, he's an orange dog that runs around. He's kind of barky and high energy. If you haven't met Smedley, oh, don't worry, you probably will at some point. And he's pretty great. He's a lot of work, but he's pretty great. Growing up, my experience of a dog was a basset hound. So they're these low, little long dogs with big, long ears, and they're not very smart. They're kind of stubborn. I grew up with basset hounds. So that's what my understanding of a dog was. And then as I get experience with more dogs out there, I learned that, yeah, a golden retriever is also a type of dog. A big giant Great Dane is also a dog. And I can start to engage in a process called assimilation. I can add new experiences into my schema and broaden my understanding of them. So we're constantly in a stage and a process of hypothesis testing, even if it's in a really informal way. We're hypothesis testing, and that's really cool. So we're going to talk about the 4 major stages in Piaget's cognitive development framework. So the very first stage that Piaget said that you entered in was something called the sensory motor stage. And he kind of marked this stage as occurring at birth. So you were basically, once you were born, you were in this stage, and then it continued up to about 2 years of age. And we call it the sensory motor stage because at this point, you are primarily gaining knowledge about the world through interacting with objects and what you sense. So all the things you see and the things you hear and the things you touch and taste. And one of the major hallmarks that is basically learned during this stage is what is called object permanence. So we're going to try an example right now, and this actually works on video too. Can y'all see my hand? Cool. Everybody can see my hand. Okay. I'm going to put my hand back there. Where's my hand? It's behind the screen. You know that if my hand goes behind something that blocks it, that I didn't just cut my hand off. Now, you have a sense of object permanence. So if I take my water bottle and put it under the desk where you can't see it, you know that it still continues to exist and have its material properties. It doesn't just fade into the ether because you can't see it. Now, if you've ever tried this with your pets, you know that your pets don't have object permanence. So Smedley has an orange chew toy that we love, and it's made up of little balls kind of connected to each other. So we call it the molecule. It basically looks like a big giant molecule. He loves to chew that thing, but sometimes he's really hard on it. So we hide it from him. We put it under a blanket, and then it's almost like it does not exist. Now, sometimes he realizes that it's still there, but generally, if we hide something from him, it no longer exists to him. And it turns out that when we're really little, we actually have this issue too. How many of you have played peekaboo with a child? And we're talking like a little kid. So do you know why peekaboo is so fun? Because when you block your face behind your hands, they think your face has temporarily disappeared. Like it has actually disappeared. They don't go, oh, Dr. Gilchrist, your face is still behind their hands. They go, oh my gosh, you disappeared. Where did you go? Oh my gosh, you came back. So they don't realize that objects continue to exist while they're hidden. Now, generally, Piaget believed that we developed this relatively late in our development, that we start, some of us start to get an idea of object permanence by 6 months of age, but it might actually be closer to 8 months. So if we put a blanket over this little plushie, an infant younger than 6 months will not look for it. They'll act like it doesn't exist. But if you're old enough, you're able to remember, no, the plushie's under the blanket. It didn't just disappear. So if I remove the blanket, I'll be able to find my toy. Now, here's kind of a catch though. Have you met babies that are under the age of 6 months? Are they really good at crawling and reaching for things and removing blankets? So here's the thing, for you to be able to demonstrate object permanence according to Piaget, you needed to be able to reach and grab for things and move around. And so we don't actually know for sure, using Piaget's idea, that object permanence happens at 6 months. It's entirely possible that it happens earlier, but the problem is that we don't have the motor capabilities to actually look for objects yet. So this was actually the work of René Baillargeon. Infants are actually more competent than Piaget actually believed, and they actually develop object permanence much, much earlier than we presumed. And the way that we do this is by doing what is called looking times. So I mentioned this a little bit on Wednesday. Somebody asked, how can we tell if babies have a preference for their mother's voice over other voices? How can we tell if babies have a preference for things that look like faces or not? And that's true, babies can't talk. They can't tell us, oh, I like that. But here's what we do know. Babies like novelty. Babies don't like to be bored. And babies spend a lot of time looking at very surprising events. So we've actually found that when babies look at things that are surprising or novel or unexpected, they actually will look at it longer than things that are expected. So because of that, we can use that fundamental idea to figure out what babies expect and what they don't. And that's how we figured out through the work of René Baillargeon that babies actually develop object permanence much sooner than we thought. And what I'm actually going to show you is a video, a very 80s video, by the way, that was filmed by Zimbardo, who is a very well-known social psychology researcher. But we're going to see that even at a very, very young age, babies have a basic grasp of the laws of physics. Now, are they doing quantum theory and Heisenberg's uncertainty principle? No. But they understand that objects can block another object's movement. And by the way, yeah, here's a joke. I don't know where Michelle is today, but I thought she'd appreciate this. I actually found this a while ago. Unfortunately, my nieces all lived in California, so I never got to do these things with them. But this is basically a comic of hiding a toy giraffe behind your back. Ha ha, your giraffe's gone forever. Learn some object permanence, dumb baby. Okay, and just to remind you, babies aren't dumb. Babies aren't dumb. They're actually capable of much, much more than we thought. Like, children and babies are not dumb. Just so we're clear. But I want to show this video. I am going to pause the share really quick so that we can watch it without like wrecking the video. You'll need to remind me to unpause that, by the way, because otherwise I'll do like the whole 50 minutes. I'm like, no, I forgot to unpause. And I know y'all cut me some slack, but I don't like making mistakes like that. Load up. We want to watch. What? It's on PBS. 6. It worked last year. It shouldn't be too hard to find though. See, there it is. All you have to do is search for it.
Schema researchers is now using ingenious experiments to discover previously unsuspected abilities of newborns and young children. Professor René Desjardins studies how babies develop the concept of object permanence.
By object permanence, we mean really a set of beliefs about objects. The first and most fundamental belief is that objects continue to exist when hidden. The first person to investigate the development of object permanence beliefs in infants was Jean Piaget, the famous Swiss psychologist. And he claimed that it's not until approximately 8 to 9 months of age that infants understand that objects continue to exist when hidden, and that it's not until approximately 12 months of age that babies begin to understand that objects not only exist but contain their physical and spatial properties when hidden. What we've done is to devise a series of tasks where the infant simply had to look at possible and impossible events.
In this experiment, a 6-month-old baby watches a cart rolling down tracks, going behind a screen, and coming out the other side. The screen is lifted to show a block sitting behind the tracks.
So that's an expected event, right? As long as it's not blocking, that cart should be able to roll just fine.
Next, the baby sees the block placed on top of the tracks. The screen comes down, the cart rolls exactly as before.
Okay, is that gonna happen in real life? No, it should stop the cart.
But in the real world of permanent objects, the block should have stopped the cart. The baby stares longer at this apparently impossible event.
When infants are surprised or puzzled by an event, they tend to look at it longer. So our prediction is always that if infants perceive the events as we do, then they will look longer at the impossible or magical event than at the possible event. What we found is that infants as young as 3.5 months of age, and perhaps younger, but certainly as young as 3.5 months of age, understand that objects continue to exist when hidden. One contribution of this research is to say that we must really take a very close look at infants' physical knowledge. It's much richer, much more sophisticated than used to be thought.
Pretty cool, huh? And that's a very, zoom share. That is a very elegant way of really designing a very, very simple experiment that actually teaches you something that we didn't know before. So Piaget believed that object permanence didn't really happen until about 6 months of age. And now we know that it's even younger than previously supposed. So I wanted to share another cool study that you might be surprised by. When I was in graduate school, I actually took a course for an entire semester solely on cognitive development. And this is actually one of the papers that we read. The professor who taught the class was actually a student and collaborator with René Desjardins. And here, this is a very simple study that was designed by Karen Wynn and colleagues that found that babies do seem to understand very basic low-level arithmetic operations, such as counting. So here's how the study works. So we have 2 objects that are placed in the case. So they set up this little puppet show stage, and babies actually watch a hand place 2 Mickey Mouse dolls on the stage. Then the screen will come up, an empty hand will come out and take away one of the dolls. How many dolls are left? There should be 1. So here's the possible and expected outcome. The screen drops, revealing only one Mickey Mouse doll. On the other hand, here's the impossible event. The screen drops and there are still 2 Mickey Mouse dolls on the stage. Guess which one the babies tend to look at longer? They look at the impossible event. They look longer at an instance where there should only be 1 doll because they saw a hand remove 1 doll, and instead they see 2. And Wynn and colleagues have indicated that this means that infants should be capable of very basic low-level counting. Now, are they going to be able to multiply and divide like you or I? No. But they do have more understanding of things like numeracy. So they're capable of things that we typically have not given them credit for. So now we're going to talk about the pre-operational stage. So the sensory motor stage goes from birth to about 2. The pre-operational stage occurs from 2 to 6 or 7 years of age. And Piaget termed this the pre-operational stage because in this stage, children are far too young, bless you, they're far too young to actually understand basic understandings of mental operations. So for example, here's my water bottle. Actually, no, I'm going to use an example of somebody with a smaller water bottle. So Mary, you have a water bottle in front of you. Is that the one that you got from the Take and Make? Cool. So your water bottle is smaller than mine. I want you to imagine that you took a full water bottle of what you have right now and you poured it into my empty water bottle. Now it's going to look like there's less water in there, but you know that they're the same amount, and they'll always be the same amount because matter is always conserved. Little kids in the pre-operational stage do not understand this. They think if you pour something from a short little fat glass into a tall thin glass, that the taller glass must have more liquid. They don't understand that even though we've made it taller, we've also made it thinner. And because of that, they can't really process both of those things happening at once. So what you're looking at here, you don't need to write this caption down. We're actually going to watch a video of it. This is a basic understanding of the conservation of matter. Matter doesn't just suddenly disappear or reappear. It always has its shape. And it makes me feel really, again, kind of sad that I didn't grow up around my nieces, because I would probably have done this with them all the time. We'll talk about some other mental operations that children in this stage cannot do in just a second, but conservation is by and large the main principle that children in this pre-operational stage, they're not capable of yet. So we're going to watch another video. So during the pre-operational stage, at the very end of the pre-operational stage, children will understand the principle of conservation. Basically, a quantity will remain the same even if its shape changes. Prior to the age of about 6 or 7, children do not understand this. So we're actually going to watch a video of this girl doing the conservation task, and you'll kind of get a look into her reasoning about this. So I'll let you write this down, and then we'll go ahead and move on to the video. So while you're waiting, or while some of you are finishing writing, I was supposed to go to the movies last night. We were going to go see Shang-Chi and the Legend of the Ten Rings. And then an hour into the movie, the sound started cutting in and out and in and out, and we could not understand what anybody was saying. So we're gonna try again tomorrow. We're gonna try again tonight. They offered me a refund, but there were like 5 people in the theater, and the other people just seemed so ticked off, like, I want my money back. And there's like 2 teenage girls in charge of this, and I'm just like, you can keep the money. Like, you need it more than I do. So yeah, we're gonna try again tonight. We'll see what happens. Fingers crossed. If it fails again, I'll just wait for streaming on Disney Plus. It's okay. All right. There we go. Where'd it go? There we go. Reload. There we go.
When you look at these 2 glasses, do you think that they have the same amount of juice? You think they have the same? Okay. Now we're going to pour this juice into this glass. Now, do you think that this glass has more juice? This glass has more juice? Or do you think that they have the same amount?
That one has more.
This one has more? And why do you think that this one has more?
Because it's taller.
Okay. Did you also notice her face when she was pouring the juice? She was like, oh my gosh, I just suddenly got more. And one explanation that's been given for why that's so amazing to them is, again, you and I can process that when we put something in a taller glass, it's probably also going to be a thinner glass. So you and I can simultaneously process that as something gets taller, it also gets thinner. And one explanation for this has been that children can, in this stage, can really only process one dimension at a time. Okay, I'm going to show you the one that really, I'm just like, if you just had done this, you would have gotten it. You'll see. You'll see. Okay. She's cute.
Okay, you ready? Okay. Does this row have more quarters? Does this row have more quarters, or do they have the same?
1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
They're the same?
5, 5.
Okay.
So she just makes it bigger.
Okay. Does this row have more quarters? Does this row have more, or do they have the same?
This one has more.
That one has more quarters?
Yeah.
Why does this row have more quarters?
Because it's more far away.
It's more far away.
Yeah, it's like more far away than it's like bigger.
Okay,
All right,
I'm gonna pause it really quick. Did anybody else just think, why didn't you count it? If you had counted it, you would have gotten it. That's what I think every time I watch it. You counted it the first time. Why didn't you count it the second time? Come on. Okay, this one, and I will say, if you don't like sharing your food with kids, this is a really good way to share your food so you don't have to give all of your food to kids. Not that you should do that. You should always share your food, but watch what happens.
Between me and you, okay?
Graham crackers. I love graham crackers.
Do you think that we shared those fairly? No, why not?
You have those in the house.
Well, what if we try this? Now is it fair?
Yeah.
Now is it fair now?
We both have two.
Oh, they're so innocent. Yeah, it blows my mind every time. Every time. I'm like, why didn't you count it, little kid? You were so close. So one of the things that is kind of clear is that by the end of the pre-operational stage, you now understand that matter is conserved. A 7-year-old child would see you split that graham cracker in half and say, no, your 2 pieces are still bigger than mine, but a little kid's not going to understand that. Now, something else that we know about the pre-operational stage is that during this time, children are very egocentric. And by egocentric, I don't mean that they're like narcissistic and thinking about themselves. It's more that they can't see the world from any other perspective but their own. When I was a kid, I thought I would make French toast for my family. Now, 5 or 6-year-old me did not understand that French toast involves putting bread in eggs and milk and then putting them on a frying pan to make French toast. I didn't know how to do any of that, and I certainly was not old enough to be able to use the stove. So I made what I thought would be a delicious French toast. I put toast in the toaster and then covered it all with syrup. And I'm like, this is really good. And I made a bunch for my mom and my stepfather. And I'm like, this is really good. They didn't like it. And how many of you have seen kids do that? They give you something that they think they would like, but they give it to you. So they give you a Barbie doll as a present because they think, well, I'd like a Barbie doll, so you must like a Barbie doll. And by the way, odds are pretty good. You might know some adults who are kind of like that too. They get you a gift that's something that they really want for themselves. So egocentrism is difficulty taking on another person's point of view. And one of the ways that Piaget looked at this was through this little perspective taking task. So you get this little 3-dimensional map with volcanoes and trees and animals, and you basically ask the child what they see, and then you ask the child what they think the experimenter sees. So we're going to watch some really cute kids do this task. This little boy in particular, like the 2 boys in this task are just adorable. So I think you'll really enjoy this a lot. All right. Uh-oh, I think Zoom froze. Uh-oh. Yeah, I think it did. Okay, we'll figure it out. If we have to cancel it, we cancel it. Wait. Yeah, we're gonna have to do that. It starts right back up when you cancel it. I dig it. No, and tab. Share screen. Okay. Right. We are not sharing our screen in this case. We'll share screen and then we'll pause it. Okay, we share screen, we pause share, we get rid of the task manager. There we go. We did it. Okay.
Can you tell me what you see when you look at that from where you're sitting? What are some of the things that you see?
A cat,
A cat.
and a tree, and a barn.
Okay, now we're going to do the same thing. Can you tell me what you see when you look at it from that stool?
An owl,
An owl.
and him.
And
What-
him.
What is that?
And him.
A goat.
A goat. Okay, is there anything else you see?
Yeah.
There, what is that?
A tree.
A tree.
And then
Another little tree.
Okay, so he's seen both sides of the map now. So now here comes the critical question. When she asks him what she can see, is he just going to mention all the stuff he saw first, or is he going to specifically say, I've seen everything, therefore you must also see everything? And he's probably not going to put it that formally.
Can you tell me what I see when I look at this from where I'm sitting right here?
owl,
Okay.
and a owl,
Mhm.
and that.
Okay, this next kid is my favorite.
Okay, so can you tell me what you see from that side?
A fox and a bone and a volcano and
Yeah.
a rock and a big fat Christmas tree.
Those captions are
Can you tell
awful.
me what I think?
Big fat Christmas tree.
A bird and a river and a volcano and a sea and a rock and a tree.
Okay, I don't know where they got those captions, and I am horrified. I am horrified and embarrassed, y'all. I'm such a prude. I'm like, oh, I did not like that at all. It was a big fat Christmas tree. How did that sound like any of that? Okay, well, that probably livened up your Friday. Okay, let me go back to resuming share. There we go. Okay, so as you get older, you will kind of recognize that other people don't always have access to the information that you have. And so this kind of relates to something related to egocentrism is what is called a theory of mind. A theory of mind is basically the idea that you recognize that you have your own mind, your own thoughts, your own knowledge and information. And you also do not assume that other people have the same knowledge that you do. So theory of mind is ideas about your own mental states and other people's mental states. And so what you're looking at here is an example of a kind of theory of mind test. This is Sally, this is Anne. Sally puts her ball in the red cupboard and goes away. Anne is a trickster. Anne's going to get up, take the ball out of the red cupboard and put it into the blue cupboard. And so the question is, when Sally comes back, where is she going to look? Now, kids that have not developed a theory of mind yet will believe that Sally has the exact same information that they do. So because they know that it's in the blue cupboard, that Sally will also go look in the blue cupboard. If you have developed a theory of mind, it's believed that you recognize that you have information that Sally does not have. And so Sally will originally go and look in the red cupboard because she didn't see what you saw. Now, what I'm going to talk about next is a little controversial. So one of the things that has often been forwarded is that it's very, very difficult for children with autism spectrum disorder to actually have a theory of mind. And I would argue that that's kind of up for debate. People that have autism spectrum disorder can absolutely do these kinds of tasks. And our understanding of theory of mind is probably much, much more complex than these tasks make it seem. So to kind of give you an example, in case you do not know, I am I have been informally diagnosed by somebody who actually kind of does this because getting an adult diagnosis is ridiculously expensive. I'm working on it. But I've been informally diagnosed with autism myself. And one of the things I can tell you is I can absolutely do this task. Now, I can also tell you that when I was in graduate school, I assumed that because I had read certain papers, that other people must have read them too. So I remember my first couple of years of graduate school, I'm like, oh yeah, I read this paper. You haven't? And I didn't mean it in a condescending way. I was genuinely surprised that I assumed everybody had read that paper. I wasn't trying to be condescending, but that can absolutely come off as really condescending. Another really good friend of mine has autism as well. And I remember his big special interest was football and sports stats. So he would sit at dinner with the rest of us talking about baseball scores and baseball history. And he'd never actually recognize that the rest of us were getting kind of bored unless we brought it up explicitly. And so you could make the argument from these examples that maybe theory of mind is still an issue, but for people with autism, the tasks probably need to be a little more sensitive than this. People with autism can actually, like, they can actually do these tasks, just sometimes. Okay, so now, one other thing that I will kind of mention that I think your book talks about as well. So we next have the concrete operational stage. This begins in about age 7 to about 11 or 12. So we call it the concrete operational stage because children have learned to basically do some of those operations that we've talked about. They can understand conservation. One of the other things that we know that they can understand is math. And here's kind of what I mean about being able to understand math. So what you're kind of looking at here, I'm going to draw this on the board really quick. So one of the things that we know about math is that you can very easily reverse mathematical operations. So if I add 3 plus 4, I know that that equals 7. A child that is in the concrete operational stage will also realize that if you take that 7 and you subtract that 4 from it, you will go back to 3. So you can very simply reverse those mathematical operations. So one of the other things, and one thing I will mention, we call this concrete operational because the operations are towards concrete objects with material properties, like my water bottle. Lev Vygotsky also said that at about age 7, we do actually find a shift toward inner dialogue. And it's been recommended, it's been suggested that from about age 6 to 7, children begin to talk to themselves more, and they do so through inner dialogue rather than talking to themselves out loud. So we also learn to rehearse and try to remember things by that inner dialogue. So if I give you a list of items to remember, you can repeat those to yourself silently. Now, there is some recent work by Abishan and colleagues. So Abishan is a good friend of mine. She's a lab mate of mine from grad school. She and a bunch of other memory researchers did these massive multi-site studies where they actually found that verbal rehearsal in children actually develops much sooner than 6 or 7, and it actually depends on the circumstances. If you'd like more information about that study, I'd be happy to share it with you. I like supporting my friends' work. And then finally, we have the formal operational stage. So this is basically the stage that ideally you are all in now and probably have been since about 12 or 13 years old. You start to think and reason in abstract terms. Now let's be very clear. Do you think the way you do now the same way you did when you were 12? I know that I don't. So there's obviously going to be some more cognitive maturation going on here, but we do develop the ability at this point to think in abstract terms. So we can start thinking about hypothetical situations that aren't actually occurring right in front of us. So for example, I could give you the hypothetical situation that we have this class on the moon next class. Now, obviously, you know that that's not possible, but you could think about it. You could envision it. You could see it happening in your mind and process it. You can also think about possible realities. So if you're trying to think about what you'd like to do for this weekend, if you're going on a trip anywhere, or if you're going to Joplin or Kansas City, you can actually think through what each of those days might look like should you decide to go on a trip. You also engage in a lot of conditional thinking. So conditional thinking is always going to be marked by an if-then statement. So for example, if I borrow my parents' car without asking, I'm probably going to be grounded for the next 3 months. So kids and teenagers in this stage do start to engage in conditional thinking. They start to realize that certain actions will start to have different types of consequences depending on the choices that we make. How about one more slide and we have a wonderful weekend? Well, I have other classes to teach. Some of you might have other classes to take. So if this is your last class of the day, lucky you. But for those of you who aren't, that's one last class in your day. So yay. Okay. So Piaget's stages do a really good job of describing how cognition might change throughout life. Now, one of the things that I've always thought was interesting about Piaget's stages is, okay, anybody else here a former gifted kid? Yeah, I was put in the gifted and talented program growing up. And so there were things that I was able to do at an earlier age than most of my peers. And Piaget would say, there's no individual differences here. Everybody goes through these stages at the exact same time. And I know that that's not true because people were saying that even at age 8, I was already able to engage in abstract reasoning. Piaget would say that's not possible until about 11 or 12. So there are issues related to order. Children show abilities sooner than Piaget previously thought, whether it's object permanence at 3.5 months instead of 6, or Dr. Gilchrist as a child being able to engage in abstract reasoning at 8 instead of 11. So in these cases, he believed, no, children aren't different in that respect. Everybody goes through the exact same stages at the exact same time. And additionally, why did things happen in this order? So we have a very descriptive way of talking about these stages, but we don't know much about why it happens in this way. And that's what cognitive psychologists and especially developmental researchers kind of focus on more today. Why do these things happen the way that they do? And so I'm going to go ahead and stop there. Hope you have a wonderful weekend. When we get here on Monday, I will set up a time for us to have a review session on Tuesday for the exam. If you have any questions on the exam, or if you can't meet with me, or if you can't make it to the review session, feel free to shoot me an email. Stop by my office hours. You know I would love to see you. Otherwise, have a great weekend. Bye, everybody. Goodbye.